Okay, so I'm going to talk through this problem as well, just because it's a little bit different than what we've seen, and there's one little thing that I want to talk about. I'll probably talk through the next one as well, but in a separate video. Okay, so I'm just going to begin by taking Fourier transforms of both sides of this equation. Um, on the left-hand side, we're going to get the the t derivative of the Fourier transform. On the right-hand side, as usual, we'll get minus k c squared times the Fourier transform of the function, and then minus minus the Fourier transform of the function. Okay, so this is where I don't know if we've done one yet where we just have the Fourier transform of the function without a derivative or multiplying it by c or something like that. But just like normal, we're going to factor that part out, and so this is going to be minus k c squared minus, sorry, I lost my place there for a second, like this. Alright, so where is it telling me I did this part wrong? What line is that? 172. Oh, I think it's I didn't add the new command here, so. Okay, that's what we get. This is an ODE for t variable, and the solution, well, this should be okay by now, I hope. The solution, well, notice we've just got the derivative is equal to a constant times the function. So remember, as far as t is concerned, k, c squared, and gamma are all constants. And so the solution then is going to be equal to the Fourier transform of C0, which is just the Fourier transform of f, times e to the power of minus k c squared minus gamma t. And I'm going to have to split this up. This is going to be equal to e to the, oh, sorry, this is a plus. Where did I make a typo? All of these are pluses. That's a plus. That's a plus. That's a plus. So this is e. I'm going to have the gamma part, so this is going to be minus gamma t. And then the rest of it, which will be this part, I'll just do a little copy and pasting. Get rid of the gamma. Get rid of this parentheses here. Okay, but let me compile this and I can talk about it. So the Fourier transform is equal to this e to the minus gamma t times this part. Okay, now this part, we know how to find the inverse Fourier transform of that. Okay, it's the standard thing. This is the normal solution. Like just that highlighted part is the solution to this equation without this gamma u term. So this is just the normal, this is just the solution to the regular diffusion equation. Okay, e to the minus gamma t, what's that doing? Well, as far as x and c are concerned, that's not a Fourier transform variable. So then the answer, u of xt, is just going to be the inverse Fourier transform of this purple highlighted part times e to the minus gamma t. So since t is not a Fourier transform variable, u of xt is just e to the minus gamma t times the inverse Fourier transform of this other part, of this part, of this part. But that's just the solution to the PDE. PT PTU equals k pxxu with u of x0 equals f of x. That is. So we're going to have is u of xt is equal to e to the, I'm going to do this as e to the minus gamma t, and then we're going to have the square root of 4 pi kt, the integral from minus infinity to positive infinity. We're going to have f of y, and then e to the minus, we're going to have x minus y squared over 4kt dy. Okay, and then if you want, you can move the gamma, the exponential on the inside there if you want to, whatever you want to do. At any rate, this is the solution to the PDE.